Okay, so sorry for the short delay. So we were discussing these graphs, right? So what if you actually taken a cycle of say 4 vertices, right? So what would happen, right? You have these 4 vertices, right? Now what would happen is that you want to color this particular all vertices. So what you can do is actually do red color here, right? Then you can actually do green color here, right? And then you can actually again do red color. Why? Sorry, there's actually the black one. I must take the red color, and then yeah, why can you actually take the red color again, right? That's actually because you have done red color here, but that's this vertex is not connected with this vertices, right? So by any means, that's why you can actually reuse your red color again. It's because you want to minimize the particular number of colors which you can actually use among your particular graph, right? Now can you actually use the green color over this vertex? If I do so, yes, it is possible, right? That then if you actually try to generalize this particular thing over the cycle of 3 vertices and the cycle of 4 vertices, then you will actually get to know that how many colors would you require for every such graph. So these all things actually generalize your statements that how many colors would you require in the graph coloring problem if you have say a cycle of odd number of vertices and a cycle for even number of vertices. Now what you can actually try is to do it for say 5 vertices and 6 vertices. 6 will be actually again even and 5 will be again odd. Now you will actually see a pattern that how many colors you are again requiring, right? And how many colors. That I will actually leave it for you and generalize the statement so that you can actually do it quickly when the exam question comes. And also the similar things actually comes up for the graphs like which are actually having mesh. What is a mesh? Is a particular graph in which all the vertices are connected, like this one, this one, this one, this one, and all are such connected among each other, right? Means it's actually kind of a mesh and having n into n plus 1 divided by 2 number of edges, or n into n minus 1 divided by 2. That's it. Okay, so similarly you actually need to learn that what questions could actually come from different set of topics, right? Like they might actually ask the properties, right? That what are the properties of groups, right? What are the properties of monoids? What are the properties of say abelian groups? What are non-abelian groups, right? Something like that they can actually ask in the exam. They might also give a particular statement that this is a particular function and whether this is a group or whether this is a monoid, whether this is abelian. So what you need to do is actually find those set of properties, right? Commutative, associative and all, right? And then you can actually try finding whether all the properties are actually getting satisfied. So for that you need to make a note wise thing into your copy, right? Like you can make the notes of what the group properties are, right? Group properties are what is abelian, right? And I must tell you that there is a sort of sequence which actually comes among that if these sort of properties are only satisfied, then this becomes this particular thing. If another property actually adds to this set of properties, right, then this actually becomes not that, but along with that another thing which might be among from this group, abelian and whatever, right? These are commutative, associative and so on. A whole class would be required to devote on this particular topic of this engineering mathematics, but these are not as much as hard as they actually seems to be, right? You just need to tackle the exact questions which might actually come into exam, and also just clarify your understanding of what these things are and how they could be actually used in the real world applications. For example, the graphs, right? Graph coloring problem might be actually required when you are trying to share the resources among different cities, and the resource could not be shared among the adjacent cities. So how many minimum number of resources you would actually be requiring among the different cities over the world? That could be a possible application which you can actually think of. In the similar fashion, you can actually think of other different problems which are actually using this sort of principles. So you must try to relate with the applications that what it could be used with in the real world, so to actually make something useful out of it and make it something important in your life so they can actually remember that particular stuff. Okay. Another things comes from these relations function and all their properties which you might have studied in your 12th also, right? They again repeat themselves, right, in this level also. Yeah, they will properly repeat, and more the other properties of the relation and these functions, set properties which will also be asked from this particular topic, right? You and propositions and FOP for sort of logic, right? You might be asked that some questions, right? These some questions for all question, right? You might be given a particular statement, you might be asked to convert it into this propagation logic that Okay, so one such example which is pretty famous in the gate exams which I've seen is that, okay, if every person has only one mother, right, that's actually one particular example, right? So what actually you used to do is actually you have to take for all, right, for all child, if y is mother of, and for some y, right, okay, if some and you will be actually given some functions like equals, and then mother of xy, right, x is mother of y, right, and then you will actually use the equal sign, right? So you will actually first build logic, right, that how you can actually represent it. So the one of the basic logic in which it can be represented is that if x and y are actually same person, right, if x and y are actually same person, then their mothers would be equal, right? So you can actually represent this way by using these sort of operations, right? If, or you can represent the other way around, right? If x and y are different, right, then their mothers would also be different, right? So something like that, right? Okay, not actually this one, right? This one would be incorrect, right? But the first one, which you can represent by using the equals, right, and the other operator which you are actually being defining of by using the sum and the all, right? So in this fashion, you will be asked different questions by putting up statements, and also some questions which are based on the interpretation of these questions, right? Okay, then you have this second topic, right, which is actually linear algebra, which actually comes for matrices, determinant system of linear equations, eigenvalues, eigenvectors, and then NU decompositions, right? So what might actually be asked in this particular, you might be asked questions regarding to determinants, right? It's actually very hard topic which actually comes into the eyes of the examiners, right? So you might be actually asked that how would the determinant would change if you actually multiply each of the element by some scalar, right? If you multiply one single row with some scalar, right? So they will actually morph the questions which will use these concepts. They will really use the eigenvalues and eigenvector concepts, right? So you might have heard of this particular equation, right? Characteristic equation through which you actually find out the eigenvalues, right? And also using this, you actually also find the eigenvectors, right? So they can actually morph the question that if you actually multiply all the metrics with this sum, that what will the impact on the eigenvectors, and what could be the impact on eigenvalues? There could be questions on the basis of this also. So you must actually have a look at those sort of questions also, right? So that could also hit into the exam. Talking to of the linear equations, right? What could actually possibly come of the linear equations, right? You might be actually given, say, 3 linear equations. You might be asked to solve this particular sort of linear equations. So the methods which you already have studied to actually solve a set of linear equations is that you actually make these all things in the matrix format, and then you actually try to convert the left hand side into the identity. Remembering something? Exactly that. You actually need to follow the similar fashion, right? Ax equals to b is the particular solution, right? And then you actually solve for x. That's why you actually need to inverse this particular a, and then you actually just keep on following this particular solution, right? There are other methods also, right, which actually comes into existence, which actually comes from the numerical optimization theory and all, right, where you are actually dealing with other sort of stuff, right? But yeah, actually that's actually a different stuff, but yeah, basic solutions would also work in these sort of questions. So you need to have a look at the properties of the matrices, equations, eigenvalues, and eigenvectors. How to actually find them would be more than enough for you without actually going to the depth theory of them. Then you can actually tackle any of the questions which can actually come. Now, coming to the next particular topic is actually calculus, right? So calculus actually comes with the limits, continuity, differentiability, maxima, minima, mean value theorem, integration, and all. As self-explanatory, which could actually come, they might actually give you a complex sort of, say, integration question with sort of different limits, right, which you need to solve by using the rules which you might have studied into your class 12 yourself, right? That yeah, they will reoccur, but not much of the questions might come from this particular era, right? Some of the questions will definitely come from this particular subtopic, right? Then you will be asked to find the maximum, minimum, and they could possibly ask. Okay, one more thing which is very hot nowadays is actually simplex method, right? You must actually focus on that. This is not directly mentioned into here, right, but that could possibly come from this maxima and minima theory, right? Because the simplest method is actually a method from the numerical optimization theory that's actually used to find the solution to a particular problem, right? You actually morph the particular one. That's a different concept, right? But it's very lengthy, right? So if you are considering the time constraint, then you might also think of leaving the particular question. But yes, simplest method is one of the questions which is really again and again asked into the exams which I've seen recently. right? So just have a look at this particular question, try solving some of the questions, right? There are multiple conditions which will come into the simplex method, like then you have the KKT conditions also might come, right? Which you, when you actually go further into that particular theory, right, and that also will actually include your row operations, column operations, and you might already have figured out that these operations take a ton of time to actually just copy all the matrices value again and again, doing all the calculation very correctly. So that actually requires a lot of precision and effort of your, that requires practice. That's why only attempt this particular question when you actually sure that your calculation speed is good, right, and you can actually do it, because at a later point of time you can also get to know that that's actually not happening, that's not converging. So you might need to stop at the particular point of time, you might need to apply a different thing, right? That's a different theory, and that also requires a different sort of a whole set of class for evaluating and how to actually do that. Okay, similar are the different other concepts. Right now it actually comes to probability and statistics, random variable, uniform, normal, exponential, Poisson, and binomial distribution, mean, median, mode, standard deviation, condition, probability, and Bayes theorem again. Now major concepts or major questions which actually come from this particular subtopic is from probability, Bayes theorem, random variable, right? These are majorly asked questions, right? So you might be asked questions about the dice, you might be asked questions about the populations, right? So you will need to tackle probability as your major aspect, right? Probability needs to be tackled as first. Just hit on your maths book, right, which you have followed in your 10th, 12th, right, and you will actually first need to brush up all your topics of your 10th and 12th probability, then only you can actually go with a better aspect into this, right? After getting perfect at the basic principle of probability and how do you actually tackle the basic questions of probability, you will actually need to look at Bayes theorem, right? Now what is Bayes theorem, right? Bayes theorem is actually just simple theorem, right, which is actually works on a basic simple formula, right, and also has a long mathematical theory behind it and also an intuition, right? So in most of the cases what you actually are given is actually a particular question in which some event is actually given, right, and some probability of some other event based on this particular event need to be calculated, something like that. You know one thing, but you have to calculate the other thing, right? So you will actually do mostly use this particular formula, right? That's actually P A by B. That's actually P of A intersection B, right? And P of B, right? This is a particular formula, right? So based on this particular formula, you can morph this particular formula, right? So for example, you are actually given a particular value of this probability that B event has actually happened, and the probability of happening this A is something like say 0.7, right? So you might be actually given something like this question. So you will see that the value of this particular formula actually formulates to this one, that is P A intersection B equal to P of B, and also you might also be given P of B. So what you can do is find the P of A intersection B by using this particular formula, right? How? You will actually go for P of A intersection B equals to P of A by B, right? A by B, that was actually 0.7, and that being multiplied by P of B, right? So in this fashion you will be actually getting P of A by A intersection B. Now what could be asked in your question might be actually P of B by A, right? So what is actually happening is that you have to find the probability that A has happened now what is the probability of happening B, something like that. So its formula actually deformulates to P of B intersection A, right, divided by P of A. And you know that P of A intersection B equals to P of B intersection A, right? So what you actually got from here, right, will actually be putting here, and you also know in the question the P of A, so that's how you actually calculate the P of B given A. This sort of questions are pretty common in the GATE and as well as the UGC NET exams, right, which you can pretty forward calculate very easily in your exams, right, because there's simple formula, just you need to remember the concept and the formula, that's it, and you'll be able to do this question very easily. Standard deviation, mode, mean, variance, these also actually come a lot. Mean might be also modulated in some format, right? Median, you already know this is just average, this is just middle value. If even numbers, then you have to calculate the median average of those two mid values, because in the even you will have 6 there and 6 there, so this will be the median, and you will actually calculate the average of both, then that will actually be your actual median of your whole sample. Okay, the mode is actually most occurring, just see which element is actually most occurring among your data set, right? And okay, the 1.4 median is that you need to sort these elements first before actually calculating the median, right? I have seen many of the students which don't sort their data before calculating the median, so they actually get different or wrong solution, obviously. Now that standard deviation, pretty common, right? You actually calculate that particular formula which you have studied in 10, 12 and always, right? So this section is what my students face a lot, right? This is the section, right, which my student actually face the most difficulty in, right? Otherwise, other than that, most of them are actually able to do that, right? But this is the one only which they actually feel more problem, okay. After that, they feel a lot of problem in, I must say, compiler design, and then they also feel theory of computation to be a little bit complex, right? Reason isn't obvious, right? But yes, some of the concepts which require a lot of practice and also the knowledge of the concept, right, is required in the theory of computation in compiler design itself, right? So more practice is and emphasis is required. Otherwise, other subjects are pretty doable, right? And the scoring ones are actually this one, right? Because you need to learn this to actually score better than what you are expected on the average, right? Okay, we will actually go one by one. Let me actually just delete all this stuff, right, what I've actually just written, right, and delete, right, and delete whatever. Okay. Now let's actually discuss a bit about this one. That's actually digital logic, right? You might have already learned about the digital logic in your computer architecture classes, right? Okay, so you have what actually comes into digital logic is actually Boolean algebra. You have combinational and sequential circuits, right? Minimization, number of representation, computer arithmetic, fixed point, and floating point, right? Okay. So from the Boolean algebra, right, you actually just relate everything to the gates, right? That how you actually solve the K-map, right? Because I have seen multiple times K-map question to be coming into the gate, right? How they actually give the question is actually they morph the question into actually force you to solve the particular K-map, right? What will they give? Okay, let me, for example, I will actually give you a particular equation that is AB plus B A something like B C, something like that, and then B C. Okay, so they will actually give you this particular question and they will ask that what is this particular expression equivalent to. So what happens is that you are not directly asked to solve the K-map, but you need to solve the K-map, right? And also the different Boolean simplification, you can also do that. Obviously there are multiple way arounds, but yes, in many of the questions K-map is a good way and the faster way to do that. So basically, you will try to reduce and remove the redundancy between the particular elements, which can also simplify the particular equation towards a particular string, which can also represent the same function as this one. So you will directly use K-map to see directly that which are actually the redundant entries, right, and then go well. Just before the exam, I will actually recommend you to practice the 3 K-map for sure. For example, you have A, B, and C here, and then you will actually just something like this, and okay, so you can also take B here and here, and then you will actually form this way, right? You might have already done this pretty much a lot of, and then you also must practice A, B, C, D one. That's actually the 4x4 K-map. If you actually just comment down, right, I will also take you towards the recap of these all concepts and how they are actually solved, what is the easiest way and the best way to do these key maps fast. Just put a comment below, right, and I will actually get you with the relevant classes and sessions, right? Okay, otherwise it's actually very easy. You will be asked to find the sum of product equation. You might be also asked indirectly to find the product of some equation, right? And okay, and you might be also asked about with the confusing terms like min terms and max terms, right? Something like that, right? So what happens is that people used to get confused, right? There is nothing, it's just fancy words, right? The min terms refers to the SOP and the max term refers to the POS. Sometimes they also might refer with sigma and pi. Pi again refers to POS and sigma again refers to SOP, right? Again the same things, right? And just you need to make a good note that which actually refers to this one, so that they can't confuse you at all, and you're very clear in your concepts, right, to solve this particular thing. what is actually happening is that behind the scenes, by using this k-map and all, you are kind of actually reducing the redundancy of finding the same solution, right? So what actually happens is that in the boolean circuits, when you actually design a particular circuit, right, you actually get the particular output, right, that okay, in this particular configuration I want 0, in this particular configuration I want 1, and in this particular configuration I want another 0, right? So the thing is that you have a very complex circuit using multiple variables like a, b, c, and on, right? So the idea is that how can we actually simplify this all circuit? How can we simplify this complex circuit into a simpler one which does the same work? That's the idea of using the Carnot map. And you just reduce the redundancy among the particular circuit, and you actually find the particular specific simple solution. This can also be used in the real world circuits when we actually design those, right? So just try to correlate your things with actual applications which you can actually use up in the real world, so that you are not left with only theory after your graduation or post graduation, and you actually learn where to actually apply the concepts in the real world. Okay. Okay, one more confusing terms actually comes out there in the exams is with the combination and the sequential circuits, right? They might actually give you a particular circuit, right? Okay, so they might actually give you a particular very, very complex circuit, right? Including the JK flip-flop, including the T flip-flop, including the D flip-flop, right? And they might ask you whether it is a sequential circuit and combination circuit, right? That's it. That also can be asked into the exam. So what you need to do is that you need to go for the jigs for jigs. I believe they have a good resource, right, for this. They actually show various different flip-flops, right, and how they function, what is their purpose, right? Something like, for example, T flip-flop, as the name suggests, toggle, right? It just toggles 0 to 1 and 1 to 0, right? That's what it does, right? The flip-flop, another particular flip-flop which is widely used in the circuits, right? What it does? Nothing. Just actually transfers the particular input to output as the clock trigger, right? So there are two types of flip-flops also, and circuits also. Yeah, one is actually synchronous, another one are actually asynchronous. Again, another whole sum of 30 minutes class would be actually required to explain it in detail. Just comment down if you actually want one. And for now, my major objective for today's class is actually to give you a bit of detail about what the syllabus is and what you actually need to study and how you need to prepare for the GATE exam, right? So that's what I'm actually focusing on for today. But yes, we can have in-depth discussion of any of the topic which is actually required. Okay, so in this fashion, we'll actually need to learn about the basic things of this particular one, right? Again, another flip-flop which is pretty famous, it is too much famous, is actually JK flip-flop, and another one is SR flip-flop, right? Okay, SR, as the name suggests, is actually a set reset, and JK flip-flop is a special one, right, which is widely used in the actual devices also, right? Is actually JK flip-flop because it doesn't have the problems which might be occurring in other ones, right? So basically it's a combination of different set of flip-flops, right? You might be also asked to identify a particular sequential circuit, that whether it is a SR flip-flop or whether it is a JK flip-flop. Just hold on your pins and then just draw the particular circuits, right, and then try practicing 1 or 2 times, and you will actually get to know that which particular flip-flop works how, and also just make the truth tables of each of the flip-flop, that how they actually works, right, and you will actually get very easily with that. Okay. Yeah, I was actually with the D flip-flop. So D flip-flop just transfers the input to the output. That's it. If you actually supply 1, then it will not be actually shown in the output. Output is generally represented by Q naught, yeah, and then negate of the output is actually represented by Q bar, something like that is the representation in the flip-flops. So what happens is that when the clock actually triggers, right, when the clock actually runs, means when you supply the particular clock, then what happens is that the input actually transfers to the output. Similar is the case for JK, and similar is the case for SR flip-flop, that when you actually supply the particular clock, then only the particular trigger or the toggle or whatever happens, whatever defines is defined in your logic. So this is how this all circuit works. And apart from that, I would also recommend you to actually draw a particular sequential counter, right, Okay, so what happens is that in a particular counter is that you actually roll among different particular things, right? You actually sequence over a particular set of say numbers, right? Like you might actually be having the output values as 0 0 0 1 1 0 1 1, right? So something like this actually is a sequence which is actually followed in a sequential circuit, and again after this particular value the 0 actually comes up. So you must actually know how to actually make a particular circuit which is producing these sort of values, and then again cycling it is very very useful, so that if in exam actually some sort of circuit actually comes, you can actually try to make the truth values of or the output of the previous. You will actually first make the previous output, then again next one and next one, and you will actually get to know that how the circuit is actually working and what it is, whether it is a combination or it is a sequential circuit, right? And then you can actually answer pretty much anything, right, which is actually asked into that particular question. Okay, minimization is actually all related to how you minimize all those circuit, right? Because as actually in the reference to the k map, right, you were minimizing the particular equation. So similar is the fashion, you can actually again always formulate your circuit into a particular equation, right? For example, you have say a, you have b, right, and then you have this particular, which gate it is, you will tell me. This is actually the OR gate, right? And similar fashion you have the C, which is actually connected to this one. So equation of this is A plus B, right? And then dot C, right? So you are doing M. So this is your equation, right? And when actually you open it, AC plus BC, well, there is less redundancy in it, but you can actually convert any circuit to such form, and then from this particular equation you can use K map and then just simplify it. Then after the simplified equation, whatever it is, you can again convert this particular circuit, and you will see that this must be the simplified version of that particular complex circuit which might be given to you, and you will be actually able to produce the same output which you have been producing earlier. So that's the basic idea of this particular whole thing and where it is used. Okay. Then you are actually with the number representation, how you actually do all the calculation and arithmetics with the numbers and the floating point fixed and floating point both ones, which will also come in this particular topic. So you must actually learn how the floating point numbers are actually stored and how the calculations actually happen among them. There are different formats also which you might refer in your books and all, that will clearly tell you how you actually do the calculation among them, or we can also discuss that later. Now you have the computer organization and architecture, right? You have the machine instructions, addressing modes, ALU, data path control unit, instruction pipeline hazards, memory hierarchy, cache, main memory, second memory, IO interface, interrupt, DMA mode, right? So let me tell you which are the hot topics from these all sort of topics, because you can't do all, right? But yes, you must know the hot topics and which are the most beloved questions which might actually come from this particular topics, right? Okay, so you have multiple addressing modes, right, which are again and again asked, right? Okay, let me actually make you remember some things. There is indirect addressing mode, there are addressing mode, there are index addressing mode, then there are immediate addressing mode, something like that. Addressing modes are there, which is actually in the book Morris Manor, right? It actually very nicely actually tells these all topics in detail, right, whether you want to dive deeper. So you must actually get to know that how the instruction is actually shown, how the instruction actually looks like with a particular addressing mode, and that's how you can actually learn that which particular addressing mode is actually working in which fashion, right? So you can just use and practice one of each of the addressing mode, and then you can actually be ready with any of the question which can actually come. ALU refers to the arithmetic and logical unit, how the question will actually come into the exam. Okay, so they might actually ask you some particular functions. Okay, so this is the particular function, which unit is actually responsible for performing this particular function. There will be option like control unit, there will be option like arithmetic and logical unit. Okay, these questions also comes, right? Now, then you might actually get confused. Okay, so these particular instructions, okay, so what we actually responsible for actually working. So you must know one example of each of the unit, that this actually performs this one and this actually performs this one, so that you can actually relate and guess that, okay, so this particular function is actually relating to that, so that unit must be doing this particular thing in the computer. Okay, then you have the instruction pipeline hazards. Pipelining is very famous and hot topic among this particular question. So how the questions will actually come from pipelining, right? You will be actually given a particular set of pipeline stages and non-pipeline instructions. Okay, so you will be asked this. Okay, what A instruction need to be performed to do a particular function, then B also need to perform C and D and so on, right? So what will happen is that they will also define you a particular stage pipeline, like a 4-stage pipeline. Okay, so the instruction actually pass from this one, this one, and this one, right? So what happens is that you will be asked to calculate the efficiency ratio in these sort of questions, right? Okay, how to actually calculate the efficiency ratio is that you will first calculate the time it takes, or the number of units, number of cycles it actually takes to actually perform it in the pipeline fashion and the non-pipeline fashion. So what happens is that in the non-pipeline fashion, what will happen is that, okay, so if you have say 4 stages, right, to actually execute a particular instructions, right, you have this one, and this one. What will happen is a non-pipeline instruction is that instruction number 1 will actually come, then it will actually go this one to this one, and this one, and then it will finish, right? And then the next instruction will come after this whole execution is performed, right, and then it will actually go into this particular fashion, right? But in the pipeline instruction, what will happen is that you have something like this hierarchy, right? So what will happen is that this is actually stage A, right? And this is stage B, this is stage C, and this is stage D, right? So okay, you have say 4-stage pipelines. So what will happen is that first instruction will actually go to this one, and then it will actually go to this one, right? But in the meanwhile, when it has actually reached to this particular stage, then the next instruction might have actually came to this one, because this was empty, right? So this must not be left empty. This must be actually kept for on processing. So the second instruction can actually come to this one, and then it will actually go to this one. On the next clock cycle, the second instruction which has came here will actually come to this particular one, and the another instruction or the new instruction will actually come to this particular stage. So in this fashion, you are not wasting time and you are using more of your resources efficiently. So that's actually the basic concept of pipeline, right? So they will be asking you pretty much straightforward question that how many clock cycles will be required to execute say 30 instructions, right? 30 instructions in say 4-stage pipeline, right? You have say 4 stages to be executed to actually perform one particular instruction, right? Then how will you actually do is that for the first one, say first instruction, it will take 4 clock cycles to complete. Just have a focus on this particular segment, it's important, right? So okay, so this is actually 4-1, sorry. Yeah, so basically you have these 4 stages, right? So after these 4 stages, your instructions will be out. Your instruction is complete. Now on every successive stage, right, plus 1, the next instruction must have reached here, and it will also come out. So you see that on the 4th stage you have 1 instruction completed, but on the 5th stage you have 1 more instruction completed. Why so? Because they were all in a queue. They just needed 1 more clock cycle to be completed here, and that's how they finished completely by going through all such 4 stages, right? So that's why just looking at this in the number 4, you can calculate how many clock cycles it will require. Just see. For the first one, it will take 4. For the all such 29, it will take only 1 second. So 29 is also only required. So 29 plus 4 becomes how much? 33. So this is the total clock cycle which is actually required in the pipeline instructions, right? Pipeline instruction. So now compare it with the non-pipeline instructions set, right? How it actually will go up. So as I've said, it will not go parallelly. There will be no parallel processing here, and they will actually go sequentially one after another. So you can actually guess how much time it will be requiring in a non-pipeline instruction. So let's say you have say 30 instructions, right? And you have say 4-stage pipeline. So just multiply with 4. That's actually 3 for 12, 120 nanoseconds or 120 clock cycles will be required. You can actually calculate the efficiency ratio by 33 by 120, and that will be your efficiency ratio. As simple as that. So you will be asked the question in this fashion, right? Okay. They might also morph questions, right? Okay, so how they will morph the questions, right? They might actually give you that particular efficiency ratio, that this is your efficiency ratio, and what could be the number of stages to achieve this, right? So this might be asked one, right? Basically you will be asked to calculate a different thing if you are actually given the efficiency ratio, right? So you will just compare it, put in the equations, and you will actually get the particular solution. My basic objective is to actually formulate the intuition behind the things, right, in you guys, right, so that you actually remember better, and you just don't need to learn on the formulas, and you actually get the concepts that how these things are working, how these things can be applied to different concepts, right, in the reality, so that you can actually use them while learning them. Okay, so now where will we okay, so here were we. So you might be also, yes, this is very beloved topic of the examiners, right? They ask a lot of questions from caches. They love this. Again, so one most pretty famous question which actually comes from this cache thing is that what is a hit ratio? Okay, so what is the time required in the cache organization, right? So that's a standard and pretty standard format to actually solve that. You will be actually having the RAM, or say main memory. You will be actually having a cache, right? So there will be some sort of say hit ratio of say 0.9, that on 90% of times you find the things into your cache, and 10% of times you actually find 10% of times you don't find the thing into your cache. So you need to actually go towards the RAM and then access that particular thing and then transfer it to your cache, and that's how you actually get the data. So how will you do that? You'll be actually given some time that is required to access the RAM, right? And you might also be given some time that is required to access the cache, right? So now what you will do is that you will just multiply with the probabilities that what would be the time, total average time which will be required in this particular organization. Okay, so let's say 90% was the time you are actually going to cache and you are getting that data which you are wanting. So say you will actually multiply 90% of times you get that, so you will just multiply it with the cache access time. So I will just write it as CAT, whatever it is, like 1 nanosecond or whatever they will actually give you in the question. Okay, so this is the best case. Will you actually go to the RAM? No, you won't go to RAM in this particular case, because you already get the data in the cache. But 10% of times you will not get this particular data here, right, in the cache, right? So basically what will happen is that now you need to multiply it with the time that whether you actually get it in RAM, right? Okay, so it will obviously be in the RAM itself, right? In the memory itself it will be there. So basically what we will do is that you will now put all the time which is required to access it from the RAM and also to push it into the cache, whatever is actually the configuration. If they say that the pushing time of the cache is negligible, then you won't take it. But in the case when it is actually given that how much transfer time is there, how much access time is there, you will multiply it with this particular statement, get how much time it requires to actually access to RAM. And also one more thing is that this 0.1% of time you have also accessed this particular cache already. That's how you actually got to know that this is not available in the cache, right? So you will actually also add the cache access time here, right? Because you have already accessed, but you have got to know that it is not there. That's why you're going to RAM. So you have access already, so time has actually been taken for you to see whether it is in cache. So that's why this time will be added here. And then you will actually add the RAM access time, because then you actually went to RAM, and this all probability of this all event happening is 0.9. Similarly, they might demorph the question if they want to make it even harder. Then what they can actually do is actually make a different organization of cache in which they have two-level cache, right? You will be actually having one level cache, right, and then you have the two-level cache, then you have the main memory. So C1, C2, and then RAM, right? So what will happen is that they might also give the hit ratio of this one, hit ratio of this one, and then something like this, right? And they will also give the access time of this one, and this one. Then you will actually need to change the simply different question, right? So okay, so this actually becomes a little bit more complex, but this is also solvable with the same principle which we have discussed. Like 0.9% of times you actually get them, so you will actually do cache 1 access time. Then on the 10% of time you actually go 0.1, you actually go for the second cache. There also you have two possibilities, that 80% of time you actually find this thing. So here you will actually add the C180 plus C280, right? So this is the scenario. But here if you didn't find, then what will happen is that you will have the 20% of time that you actually don't get it here, right? So for those 20% of time, you have a wastage of this much of time, this much of time, and this much of time, right? So we'll actually just add cache 1 access time, cache 2 access time, and then RAM access time, something like that. So this will be your formulation, and this is how. Now you can generalize it to 3-level cache, 4-level cache. Well, there doesn't exist something like that, or might exist in complex system. But essentially you will be asked only till 2-level cache or 3-level cache, whatever the records say for the gate examinations and also net examinations. Okay. They are not there to threaten you, they are there to just judge how much knowledge you have. So they will actually give the questions which are solvable, but yes, you need to practice a little bit. Okay. Then you have the second story, IO device. Okay, DMA is also pretty famous question, right, in their eyes, right? They might ask, say, which modes of DMA transfer are there? So you need to learn modes of DMA transfer, right? DMA transfer, right? So what will happen that there are different modes like cycle stealing mode. Then you have the burst transfer mode and something like that. There are different sort of modes out there for the DMA transfer. So you need to actually have a bit knowledge about what each mode does and how it actually performs, what happens to the control lines, and how the different lines like data lines and control lines behave in such a fashion. So they actually ask it pretty frequently in this particular case, right? Then you have the programming and data structure questions, right? Like you might actually be given programs in C. Many of you might be very confident in this particular section, right? Because you already know, many of you know C very well, right? So you can actually do very much easily these sort of questions, right? I'm also very fond of these sort of questions, right? Because they give very interesting output questions, right? In this particular case. Now, some examples of these particular output question might be actually using the pointers, right? And then might be actually referring to pointers to some arrays, right? And they might be using multiple levels of the star operator, right? Like value add and value add, value add, value add, value add. And then they might be modifying it with plus plus. They might be using these plus plus operators with these particular pointers, then to just confuse you. They might be actually giving some sort of questions like array and something like 1 2 3, and then they might be actually outputting some say array fourth question when there are only three elements. Then they will actually give options like it's actually printing for something like garbage value, but if you know that this actually will create an error of array index out of bounds, so you will actually take the right option. Otherwise, some might actually also take this question. So this is the way they try to confuse you with the pointer arithmetics and how the address actually works, right? How the pointers actually works and what will the okay. So one other pretty famous question which actually comes in this one is pointer arithmetic related to pointer arithmetics is only. So for example, you have say particular value a is equal to something, then they actually pointer to this particular value. They will just add something to the value of this particular pointer, so the actual value will also be changed to 20 to 21, and then they will actually just print out a, right? So that's how so the output will be not 20 but 21. So they just want to see whether you know that pointer arithmetics works in such a fashion. So there will be questions like this one, right? There are a lot of questions which I've seen from these particular topics in the gate examinations, right? And they ask one. Other questions actually comes from the recursions, as always, right? They always ask recursions, right? Just to confuse the students, right? Now how you must actually approach the recursion questions, right? Some of you might actually try as first way that how just to make the tree, that how it's actually forming, then just calculate and go up. But another approach could be to actually find the pattern, how it is actually going up, and how to actually guess the best case, or how to actually guess the end case by just following the pattern. So we'll actually see a particular pattern that this particular unit is actually getting called, and the base case will be called in this particular case when this array will actually reach to this particular length. So let's actually have a look at those aspects also, so that you don't have to solve this whole tree but still be able to actually get the answer very nicely, right? So these are tricks which you must actually keep in mind to actually solve the things faster. Okay, then there are arrays questions, stacks, queues, linked lists, trees, binary search tree, binary heaps, and graphs, right? These all questions will come, and they might also ask you to that whether a particular function is doing what, right? And they might actually give multiple explanations, right? Okay, so this one matches, okay, this also is also a probable one. Then they might also ask questions from binary search trees, in order, reorder, cross order, that what in order actually looks like, what post order will do, right? And they might ask you what in order produces, so you must know that it produces the sorted order of elements, right? So you must actually be matching with the correct option according to this one. So questions from this particular section comes like this, right? And then we have say other sections, right? Okay, so I believe for this particular video we must actually um, only do till this one, because it's actually getting a lot longer, right? But yes, I have actually discussed in a bit of detail that how the questions would must look like in the GATE 2026 examination, right? This time, right? By analyzing the past questions, right, and by following the particular pattern which GATE and other particular organizations are actually following now. So if you wanna get the detailed video of any such topic which we have discussed today, you can put a comment below, right, and any other suggestions are actually welcome. Thank you so much, guys, for being here. Best of luck for all of you guys. Bye bye.